Our next speaker is Lee Pucker. You join us online. Lee is the CEO of our sponsor WINForum. But Lee, welcome. I'll be driving your slides.
Thanks everyone for having us and joining. A little bit about who the Wireless Innovation Forum is. We were formed in 1996, actually, as a nonprofit mutual benefit corporation. We're effectively a standards development group. We're incorporated in the state of California. We were originally created as the MMITS forum. I have no idea what MMITS means anymore. In 1998, we became the Software Defined Radio Forum, or the SDR Forum. And then in 2010, we rebranded as the Wireless Innovation Forum. We're registered. I'm sorry, is there a question?
Nope.
Okay. We're registered with the United States Department of Justice as a standards development organization under the National Cooperative Research and Production Act of 1993, as amended by the Standards Development Advancement Act of 2004. What that means is that our members are able to cooperate and collaborate to develop standards for the wireless industry. Along those lines, we've been involved in spectrum sharing probably since 2004, when we were still the SDR Forum, and we had a cognitive radio work group that was working to develop standards along the way. We were involved in the initial development of the TV white space standards that were used in the US, and then that fed into some things that were developed worldwide. And we've been involved in things that Charles mentioned previously for CBRS and 6 gigahertz, and I'll talk a little bit more about that as we go. So if we can go to the next slide. There we go. So how are we organized? I'll be very brief here. We currently have 4 active committees that are reporting to the board of directors, and I'll talk about some of the activities in each of these related to spectrum sharing as we go. The first is our Wireless Innovation Committee, and that group is focused primarily, it acts as an incubator for the rest of the forum, and bringing in new ideas and new things that we need to be working on, and then spinning those off into what we call commercialization committees as technologies mature. We have 3 commercialization committees. The first is our Software Defined Systems Committee. Participation in this is mostly by radio manufacturers and associated companies worldwide supporting NATO. We have participation from companies like L3 Harris, Leonardo, Indra in Spain, Thales in France, basically radio manufacturers all over the world looking at software-defined radio and software-defined systems architectures and standards. We have a CBRS committee developing the standards for CBRS that Charles mentioned a minute ago. We have a 6 gigahertz committee developing standards for the 6 gigahertz band, again, that Charles mentioned a minute ago, and then all of that's reporting up to the forum's board of directors. We can go to the next slide. So let's start with the 6 gigahertz committee. Go on, there we go. So the sharing in the 6 gigahertz band in the United States really covers the entire band. We have standard power in the 6 gigahertz lower and 6 gigahertz upper, and then low power indoor for the whole thing. In addition, there's a potential report and order coming out soon allowing for very low power indoor. This is a little bit different than sort of the rest of the world that really focuses on the lower 6 gigahertz. We're in the US, we're taking up the whole thing. Go to the next slide. There we go. So our involvement in this was joint with the Wi-Fi Alliance. We have a pretty strong liaison agreement with the Wi-Fi Alliance. And if you see here, these are kind of the artifacts that we developed. So the WInnForum took the rules developed by the FCC and developed from those requirement specification covering all aspects of what was necessary for the AFC system to be deployed. At the same time, the Wi-Fi Alliance was developing AFC interface specification. That's the interface between the AFC system that does that lets devices know what frequencies are available and the actual devices that they're communicating with. And then collectively, a AFC system test compliance plan was developed. The Wi-Fi Alliance drafted it, sent it to us, we reviewed it and mapped it against the requirements using the traceability matrix to make sure that every single requirement in the requirement specification had a test against it. The results of that was then used to generate a set of AFC system test vectors. Again, the WInnForum reviewed these test vectors to make sure that all the stakeholders within the WInnForum agreed with that the requirements stated in TS 1014 were being met by the test vectors. And then the WInnForum's members developed a test harness to exercise the AFC systems under test by the test labs to make sure that they met with the requirements that the FCC had imposed. In addition, we developed a set of supplementary databases. We had a standard for that, and then a number of databases were developed. Things that were included in that include things like billboard reflectors, antenna models, things that were necessary for an AFC system to be able to query in order to determine what spectrum should be available in a specific location of a specific device. All of this was agreed to by the FCC, and if you look in the proceeding, you'll see that the FCC allowed for these artifacts to all be used in proving that AFC systems, when tested, met with the requirements in the FCC rules. And the result of that now is that there are currently, I believe, 7 AFC systems that have been certified by the FCC, and there we go. And a number of equipment manufacturers have had their equipment certified following similar process. Remember companies like Cambium, Cisco, Aruba, Hewlett-Packard Enterprise, Ruckus Wireless, Toronto Wireless, all have had their equipment certified for operation in 6 gigahertz band in the US. The total effort within the WInnForum in developing this capability, we had roughly 56 organizations participating across all the different stakeholders that were involved, including incumbents, new entrants into the band, and 173 specific individuals were involved in the process. So we can go on to the next slide. Some ongoing efforts. We're looking in 6 gigahertz. We're looking at the potential DLP proceeding. There was a second NPRM related to geofenced very low power, and we're looking at some technical requirements related to that. Cleaning up a few leftover issues related to data interference analysis, international crossover. And then we're coordinating with the Wi-Fi Alliance on test vectors for Wi-Fi 7. So the next slide, please. So next I'll go into the CBRS committee, and we can actually skip this because Charles gave a good introduction as to what CBRS is. So we'll go to the next slide. So our standards for CBRS are kind of in 3 buckets. The first is what we call Release 1, and those were the baseline standards that were used for initial certification. Industry extensions to Release 1 are captured in what we call Release 2. Those are enhancements in baseline standards addressing industry need. And then we have a bucket called Release 1 Plus, which is things that are addressing regulatory changes that have been allowed since Release 1 on top of the baseline standards. And I'll talk about each of these in a little bit of detail. So go to the next slide. So the baseline standards developed for CBRS, there were 10 of them, starting with operational and functional requirements, communication security, operations security, moving all the way up the stack. And then we also included test and certification specifications for both the spectrum access system and CBSDs. We developed test harnesses that could be used by test labs to exercise the equipment, SAS test harness that was used by ITS in certifying the spectrum access systems, CBSD test harness that was used by various test labs in certifying equipment. We also had to develop a number of related things, a measurement database, air interface database that were extensible to allow any user to register what they're actually going to be accessing the CBRS system with. And then we had to establish 3 accreditation programs. We set up to approve accrediting the CBSD test labs. We approved a number of PKI certificate authorities to provide the security root of trust for use in CBRS. And then we accredited certified professional installer training programs to allow professional installers to be trained to install CBRS equipment. Participation in developing these standards was 60+ organizations across the entire ecosystem, with roughly 300 participants involved over the process. The results to date, Charles mentioned, we've had over 400,000 CBSDs that have been deployed. During the PAL auction, roughly 17,000 priority access licenses were awarded. There are currently greater than 350 CBSD models that have been approved by the FCC using the WINForum's CBSD test specification and test harnesses. And then we currently have almost 6,000 certified professional installers capable who have been trained to do the installation on this equipment. Go on to the next slide. So jumping to Release 1 Plus, there have been a number of changes that have occurred in the specifications and standards based on work that the Spectrum Access System Administrators have been doing with what's called the IJWG, or which is a group of government agencies responsible for CBRS, to really improve the deployment characteristics for CBRS. Better propagation models that take into account clutter, being a little bit more conservative on assumptions regarding propagation losses, especially given that there have been no reports of interference in the band. Looking at refined considerations for power output, and looking at the requirements for checking in with SASs and making those adjustments. NTIA has posted to the FCC letters indicating the things that have been agreed to, and then the FCC has adopted those as a part of how CBRS works in a series of public notices. An important thing to note, you'll hear the term CBRS 2.0. OnGo Alliance, another industry association, has basically adopted WINForum's Release 1 standards as a part of their CBRS 2.0 initiative, which is really looking to promote these new capabilities in more detail. Go on to the next slide. There we go. So a little bit of an example of how these new propagation models work. protection of Navy incumbents is supported in CBRS through what's called a dynamic protection area. The sensors are basically sensing these various areas, and so if a Navy ship is operating a radar within one of these dynamic protection areas, the sensors will detect it and then pass that information on to the spectrum access system, which determines if anybody in a DPA neighborhood associated with that dynamic protection area can interfere with naval operations. If they can, then they get shut down and their spectrum, either a new spectrum assignment reallocation, or they get turned off until the Navy operations are no longer ongoing. So if you go to the next slide, there we go. So here's a typical example of the improvements that were just made in Release 1+. This is for Category A, so indoor below 6 meter devices. If you look at the red on the map, you'll see this is the area that was originally the DPA neighborhoods. And then with the changes that they've made in the models that are currently being used, the green lines show the new operation. So the impacted population for this one change, and there were several changes that have been added on, is about 40 million people. So a significant improvement in available spectrum and significant improvement in the assurity that once you have a connection, you'll be able to keep it and won't be interfered with by naval operations. So next slide, please. So briefly on Release 2, we have what we're looking at for Release 2 is really kind of an a la carte adoption of plug and play features. Things like enhanced antenna patterns, updating the grant availability, a whole host of things that industry has said that they need in order to be most efficient in the use of CBRS. Those standards are available, and it's kind of an ongoing development to improve them as we go. Next slide, please. Finally, a lot of the work that we've been doing recently is there's a new CBRS NPRM that's out, and we have been developing comments, which we'll be filing actually early next week, since that's the deadline for the CBRS comments. We'll be filing comments for CBRS next week, and you'll be able to see those when they're online. So flip quickly through the Wireless Innovation Committee. Go to the next slide. I'm not going to go over this slide other than it's in the deck. You guys can get it. There's a number of work groups with ongoing projects. I will jump to the next slide. Try and keep it in the time that Prakash asked me to cut it down to. We have a 6G work group. This group is really looking at spectrum sharing in 2030 and beyond. So we're looking at definitions for 6G, the role of spectrum sharing in 6G, what innovations are required to move things forward, and sort of coordination with all the various groups that are involved in 6G moving forward. The next slide. The current project that they're working on is looking at the 7-8 gigahertz band. They're doing a technical report as to how 6G can operate in the 7-8 gigahertz band. But there's additional work being done through some workshops and other projects ongoing. And go to the next slide. We have a midband sharing work group, which is looking at the entire midband spectrum. A lot of focus recently has been looking at the 3450 all the way up to 4000 megahertz. the 3 bands, the C band, the CBRS band, and the ambit band in the US, which are all co-located with each other or adjacent to each other, and looking at the potential interference issues that are associated with each. Underneath the mid-band sharing work group, if you can go on to the next slide, we have formed a highly dynamic spectrum sharing task group that's looking at how we can be much more dynamic. The spectrum access system and AFC systems are relatively static in their deployments, and we're looking at how we can be much more dynamic in developing and supporting spectrum sharing frameworks. The initial work in this group is focused on the US 3.1 gigahertz band and seeing how we can support the development of a spectrum access like system that can support airborne incumbents and other fast moving mobile applications, looking at equipment and devices, looking at both centralized frameworks like spectrum access system and decentralized frameworks that would spread the spectrum access capabilities across various devices, really looking at a whole host of things in this project as to how we can move forward. One of the goals for the 3.1 gigahertz was to inform, if we go on to the next slide, is to inform the demonstration projects that Charles mentioned earlier, and then looking to understand the requirements in 3.1 and eventually 7.8 and other bands. So that was my cut it down to 20 minutes talk. And I guess if you go to the final slide, are there any questions?
Thank you, Lee.
Thank you, Lee. Any questions?
I have a question in the room from Reza.
Thank you. Thank you for that presentation. Just a question. You mentioned 400,000. Is that devices? And is that in the PAL layer or in the GAA layer? And what are these devices used for? What are the use cases? CBRS.
So it's 400,000 CBSDs. Each CBSD can support, a whole host of end user devices. So I don't have a count for number of end user devices that are connected to these CBSDs. It also, the CBSDs are in PAL and GAA. It's in all the various bands.
I have the ability to go to PJ. I don't want to steal any of your thunder for tomorrow.
So he's presenting.
Yeah, so if you are patient enough, tomorrow I will present the CBRS by the numbers, and you will have exactly the counts of those 400,000 CBSDs, how they use the band, where they use it, how they are deployed. So it's really going into the very detailed of really a screenshot of CBRS as it is today.
You'll come tomorrow, Reza.
Yes.
Okay. Have we got any questions? Thank you so much, Lee.
Thank you, Lee. So nice to report you on the West Coast.